Okay.
All right, we have a remote mount pump. It can be mounted anywhere. Basically supplies all the vacuum need for the feeder. I mean, the pump doesn't have to be on to make the feeder run. It's just for glossy pieces. When they get print powder on the belts, the vacuum assists it in feeding, so you don't almost never have to clean the belts. So we have friction as well as vacuum feed. So I'll leave the pump on, but right for testing first, so you can hear me, I'm going to leave it off. Basically, we have an interface box here, which is going to simulate what you have currently. And when we set this batch count to what we want, when your printer comes online, it will send a command to start running, okay? And feed out like we told it to feed 10 pieces, so that's what it's doing right now. You look here in the screen, it gives the status of where the PLC is right now, or the feeder itself. It's in a stop mode, and it says basically the count has been at 0, so it reset to 0. If we hit this key here, the right arrow key, it will bring you to a main menu, which is menu 1, and mode equals 0 would be for the application that you're doing. There's another mode that I've programmed in there. It's called mode equals 1, and that is for standalone or coupled to an indexer or some other control feed method to deliver them in time to like a polybagger or whatever. It's some previous applications that I've done. I threw it in there because who knows, in the future you may want it. We have, if you'll see here, it says mode equals standard. That's a standard for you to run. That will mean it will be coupled with the inkjet and looking for signals from the inkjet to make this enabled. Set is the number of set pieces which you want to batch. To change these numbers, you'll see there's a blinking cursor. If I hit the enter key, it will move the cursor down to the set. I can type in 100 right here and hit the enter key here. And if you notice, if I can't see with the camera in the way. Let's get the cursor back on it. I hit 1, 0, 0, enter. Now it's batched out for 100 pieces, 100 sets of 100. The batch I have set to 0. Batch is for when you want to run standalone and no interface, and basically the feeder will sit there by itself. It will run out the predetermined set amount, and each time it does 100 pieces, let's say, which we have it set for, it will count the batches of whatever amount. Maybe you want to do 1,000 batches of 100 sets. It will keep doing it, and it will pause in between each batch to let you know that it is done. It just doesn't run continuous without stopping. It'll give you a visual stop and say it's in a pause status. And it waits for you to start, hit the start button again to start the event, or it could be automatic and start up automatically. We have another screen, which is if we keep hitting the right arrow key while we're hitting enter. Index delay is basically for mode 1, which you're not using. This says when I see the command to go, how long do I want to wait? Then we have another item here is called watchdog. Basically, if we're running and we know the process takes 1 second to deliver a card, I'd set it for 2 or 3 seconds. If the sensor stays blocked for longer than the period that you've entered here, it will stop it and say there's a feed error. It's basically to prevent a jam from becoming a catastrophic lockup on the feeder, so that it becomes an intelligent feeder. It knows when it ran out of material, or if it stayed blocked for too long, then it would shut the feeder down, and it would throw the red light and give you an indication of what the reason it stopped for. If we go to the next screen, this is your batch delay. If you were batching out sets, we would enter a value here of how long to pause between batches to automatically start up again. And this other one is double detect. We have it on 1. 1 is on, 0 is off. So basically, right now we're running with the double detect on. And just as a keynote, when you do get a double in the feeder, we do not count that into the totalizing count for the set. When you say it's 100 pieces, we only count 100 good pieces. We consider every piece bad till it passes that sensor without an error. So we will not increment the count unless we have a piece travel through the sensor and it sees the trail edge of the piece with no errors. And what it's going to give you, it's going to give you a more accurate count. You will literally run out 100 pieces. You could have 50 doubles in this batch of 100, and you won't get 150 cards. You will only get 100 cards, because obviously we will not add count to that number. So we only count the good cards. So pretty much the inkjet will start the event, and what it'll do is it'll start counting. As you can see, it's counting. And we're going pretty fast rate, up in the 60s, 70s right now. And we need the pump. I'll turn the pump on. And we got a double. So basically remove the double, reset. It will hit its batch count and reset to 0. It just hit its batch count of 100 cards. So we can do any value. I'll just tell it 10 cards. If I come in here and I tell the inkjet to start, that's 10 cards. Or you can simply just hit the start button to start the event as well. 10 cards. You have speed control. You can speed them very slow. And we got ridiculous speeds as well. But obviously, if we go beyond this point, we're not going to be able to stop the motion of a double. At that point, we'll be counting very accurately at them speeds. The problem is, it's like trying to stop a train within a 10-foot area at 60 miles an hour. It's just impossible. I can stop this feeder ridiculously fast, but obviously we want to stop the double before it's exited the machine, because once it's hit the inline process of the inkjet, it'll be very hard to extract it. You're going to have to manually extract. If we're at, I think it's almost 80 or 90% of the way up, we will stop that piece right here. And when it gets a double, it has to be removed before it'll allow you to start up again. So I've programmed that into that as well. We have a sensor here. This is what's doing all the counting and the double detection. It is a fiber optic. It's a high emission fiber laser detector. You'll see here, because we see a piece here, it's a single piece, the single output light is on, showing that it sees the status of a single piece. If I were to block, you will see the double LED come on, and it sees this piece now as a double. So when you remove documents while this is in a standalone mode, it will not affect the count. The only time this guy counts is when he's in a run status. So we can pull stuff in and out, and it will not affect the count while it's in a sitting idle status. Okay, we have a switch here, which you can switch to input 1. Input 1 is the piece detection sensor, and input 2, or switch 2, would be the double detect portion of the sensor. It basically, what you're doing, when the sensor array is empty, we hit the set when it's on 1, and then there's nothing there, and then we put a piece in there and we hit it again. It will be trained for that piece, the presence and absence of that piece. In double mode, we will do the same thing. We will switch the switch over to 2. We will hit it open. We will hit set with nothing there, and the sensor open. And then we would put 2 pieces in there and hit it again. And then it will exclude a single piece for viewing. But if you notice, we can move this, and the double output never comes on. It doesn't see it. It's looking for a threshold of light emission greater than what we've trained it for. So if you see, when I remove this piece, the double number 2 is on, and then when I remove the document, number 2 is out. So it only recognizes a single document as being a good document. And setting the sensor is critical, because your batch count will only be as good as you set the sensor. It's not hard to set, it takes literally seconds, and you'll have to do it anytime you change a different type of material. But once it's trained, it retains its memory of what them settings are. It's a pretty robust sensor. It has lots of functions that we're not even using, but for the most part, very easy to train. We have a button here. We can actually just scale up and down the threshold of toggle. If we're seeing something and the sensor may not toggle on a certain portion of the card, we can adapt the threshold. Obviously, if it's in position 1, we're affecting the way it counts, so we can make sure that the sensor is toggling very cleanly on a single piece and not double toggling on a single piece, because obviously that would affect the count. But so far in testing, it's been pretty straightforward. I train it, run it, and it's been fine. I don't know what else to include in it.